The entries in our table contain the sum of the two dies. For example, in this square, die 1 was a 5 and die 2 was a 3, so the box contains 5 plus 3, which is 8. To complete our table, we can fill in the blanks by adding together the numbers on the two dice. In this square, we rolled a 1 and a 6, so we should write in 1 plus 6, which is 7. Here, we had a 2 and a 5, so we'll write in 2 plus 5, which is also 7. In this box, we had a 3 and a 4, so we'll have 3 plus 4, which is 7. Here, we had 4 and 4, so we'll have 4 plus 4, which is 8. In this box, we had 5 and 5, so we'll have 5 plus 5 is 10. Finally, over here, we rolled a 6 and a 6, so we'll write in 6 plus 6, which is 12. In part 2, we want to find the probability of getting a total of 7 or 11. We should think about both these cases. Starting with the 7, we have 1, 2, 3, 4, 5, 6 boxes in our table that contain 7. So there are 6 ways we can end up with a total of 7. When we focus on getting a total of 11, we'll see that there's only 2 squares which contain 11. So there are 2 ways to get an 11. If we want the probability of 7 or 11, we should combine these scenarios by adding. Together, we have 6 plus 2, which is 8 ways to get a 7 or an 11. Our table contains 6 rows and 6 columns. This means that the total number of entries in the table will be 6 times 6, which is 36. So, there are 8 ways to obtain what we want, a 7 or 11, out of 36 total possibilities. So our probability here is just 8 over 36. In the next part, we must find the probability of getting a prime number as our total. Well, a prime is a positive whole number which has exactly 2 divisors, 1 and itself. The numbers in our table range from 2 all the way up to 12, so we should consider which numbers are prime in this range. 2 is a prime. 3 is also a prime. 4 is not a prime since it is divisible by 2. 5 is a prime. 6 is not a prime since it is divisible by 2. 7 is a prime. 8 is not a prime since it is divisible by 2. 9 is not a prime since it is divisible by 3. 10 is not a prime since it's divisible by 2. 11 is a prime, and 12 is not a prime since it's divisible by 2. So the prime numbers between 2 and 12 are 2, 3, 5, 7 and 11. Just like the second part of the question, we can count up the number of ways we can get each of these numbers, and then add all these up to find the total number of ways to land on one of these. There's just one way we can end up with a total of 2. There's 2 ways to get a 3, 4 ways to get a 5, 6 ways to get a 7, and 2 ways to get an 11. Adding all these up gives us a total of 15 ways to get a prime number. As we saw previously, there's 36 entries in the table. 15 out of these 36 are prime numbers, so our probability is 15 over 36. Given a car, this question focuses on two properties of that car. Is it a Ford car or a Renault car? And is it a red car or a not red car? Let's break down the different combinations. We know that we have 18 Ford cars and 12 Renault cars. 7 of the Ford cars are red. Since 18 minus 7 is 11, the remaining 11 cars must be not red. We know that 4 of the Renault cars are red. Since 12 minus 4 is 8, the remaining 8 must be not red. We are interested in the probability of a Ford car or a car which is not red. As long as our car satisfies one of these properties, then we're happy. If it satisfies both, then all the better. We had 7 Ford cars which are red. Since these are Ford, we'll want to include them. We had 11 Ford cars which were not red. This satisfies both our properties. It's a Ford car and it's not red, so we'll want to include these. We have 4 Renault cars which are red, and this does not satisfy either of our properties. It's a Renault car, not a Ford car, and it's red, so it isn't not red. We won't want to include these. Finally, we had 8 Renault cars which were not red. Since these are not red, we will want to include these. So, we have a total of 7 plus 11 plus 8, which is 26 cars being Ford or not red. We know that there was 30 total cars in this scenario. Since we have 26 out of 30 of the cars being Ford or not red, our probability is 26 over 30. We are told that V is the midpoint of the line segment P to R. The midpoint formula on page 18 of the formula book will help us here. It says that the midpoint between x1, y1 and x2, y2 is x1 plus x2 over 2, comma, y1 plus y2 over 2. V is the midpoint of PR, and we know the coordinates of both these endpoints. P is equal to 7, 10, and R is equal to 11, 4. To use our formula, we'll label our first point x1, y1. Here, x1 is 7 and y1 is 10. We'll label our second point with x2, y2. So we've x2 equal to 11 and y2 equal to 4. From here, we just need to sub into our formula. 7 plus 11 over 2 is equal to 18 over 2, which is 9. 10 plus 4 over 2 is equal to 14 over 2, which is 7. So our answer here is that the coordinates of V are 9, 7. We are asked to show that two lines are parallel. A key point here is that lines are parallel if they have equal slopes. If we find the slope of UV and the slope of QR and show that they are equal, then we'll know that the lines are parallel. Since we want to use slopes, we should look up the slope formula on page 18 of our formula book. It says that the slope m between x1, y1 and x2, y2 is m is equal to y2 minus y1 over x2 minus x1. The first slope we need to calculate is uv. We know the coordinates of these points. U is 4, 6, and in part A we found that v is 9, 7. We label our first point, u, with x1, y1, and we label our second point, v, with x2, y2. To find our slope, we just need to sub these values into our formula. Seven minus 6 is 1, and 9 minus 4 is 5, so our slope here is 1 over 5. Now we'll have to calculate the slope of QR. Q is equal to 1, 2, and R is equal to 11, 4. We'll label our first point with x1, y1, and our second point with x2, y2. To find our slope, we'll sub these values into our formula. 4 minus 2 is 2, and 11 minus 1 is 10, so we get 2 over 10, which simplifies to 1 over 5. This is the exact same as the answer we got earlier. Since the slopes of the lines are equal, we can conclude that the lines are parallel. We are asked to find the area of the triangle PQR. A formula on page 18 of the formula book will help us here. It says that the area of the triangle enclosed by the origin 0, 0, x1, y1 and x2, y2 is a half times the absolute value of x1, y2 minus x2, y1. A crucial part of this formula is that one of the points must be the origin 0, 0. So to use this, we must shift one of our points so that it becomes the origin. We are concerned with the triangle PQR. Let's list out their coordinates. Q is 1, 2, P is 7, 10, and R is 11, 4. We'll need to shift one of these so that it becomes the origin. We could pick any of these points, but I'll choose Q since it contains the smallest numbers. So, the question to ask is, what must I do to Q to make it turn into the point 0, 0? Well, the x-coordinate is 1, and to make this 0, all we have to do is subtract 1. The y-coordinate is 2, and to make this 0, we just need to subtract 2. So our translation is to subtract 1 from the x-coordinate and subtract 2 from the y-coordinate. We must apply the same translation to P and R. P has an x-coordinate of 7, so subtracting 1 would give us 6. It has a y-coordinate of 10, and subtracting 2 will give us 8. So after we translate P, we get 6, 8. R has an x-coordinate of 11, and subtracting 1 gives us 10. It has a y-coordinate of 4, so subtracting 2 gives us 2. So after we translate R, we get 10, 2. We've now gotten ourselves into a position where we can use the area of a triangle formula. We've translated Q so that it becomes the origin 0, 0. The next point, 6, 8, gets labelled with x1, y1. And our other point, 10, 2, gets labelled with x2, y2. From here, it's a matter of subbing into our formula and performing the calculations. 6 times 2 is 12, and 10 times 8 is 80. 12 minus 80 is minus 68. Now, let's deal with these vertical bars, the absolute value. These mean that we should turn the number positive if it isn't already positive. So the absolute value of minus 68 is plus 68. Finally, a half times 68 is 34. Area is always measured in square units, so that's the unit here. The translation UV with an arrow over it is the movement required to get from U to V. We know that U has coordinates 4, 6, and V has coordinates 9, 7. So how could we get from U to V? Well, the x-coordinate changes from 4 to 9. So the shift here is plus 5. The y-coordinate changes from 6 to 7, which is a shift of plus 1. So the translation here adds 5 to the x-coordinate and adds 1 to the y-coordinate. The point S is defined to be the location obtained after we perform this translation to Q. The coordinates of Q are 1, 2. To find S, we just need to perform the translation we had. Add 5 to the x-coordinate and add 1 to the y-coordinate. 1 plus 5 is 6, and 2 plus 1 is 3. Hence, the coordinates of S are 6, 3. We need to consider all the possible arrangements of the letters of the word rainbow. An important thing to observe is that our word contains 7 distinct letters. In other words, there's no letter which appears twice. So, how many ways can we arrange these letters? Well, we have to use all 7 letters, so we can think of this like the following. We've 7 empty boxes, and we'll need to fill one of our letters into each of these. For example, we could fill in the letters in the order N, I, B, W, A, R, O. This would be one possible arrangement of the letters. And it's worth pointing out that there's no requirement that we come out with a sensible English word, we just want any arrangement of the letters. So how many total arrangements are there? Well, we've 7 boxes to fill, so we can break this down into 7 small decisions. What should I write in each box? For the first box, we could choose any of our 7 letters. So we've 7 choices. As an example, let's say I pick A. When it comes to the second box, things are more restricted. Each letter can only be used once, and I've already used my A. This means that we've 6 choices left for the second box. R, I, N, B, O, and W. As an example, let's say I fill this in with I. Now, when it comes to the third box, both A and I have been ruled out. So there's 5 choices left. R, N, B, O, and W. As an example, let's say I fill this with an O. When we get to our fourth box, A, I, and O have all been ruled out. So there's only 4 choices left. As an example, let's fill this with a B. So hopefully you can start to see the pattern here. When we move to the 5th box, we can't use any of the 4 letters that we used already. This leaves us with 3 choices remaining. Let's say we fill it with a W. When we move to the 6th box, we've used 5 of our letters, and the only ones remaining are R and N, so we have two choices for this box. Let's say we choose R. When we come to the final box, we've already used 6 of our letters. The only one remaining is N. So there's not much choice here, we only have one option. It must be N. So, how do we find the total number of arrangements? All we have to do is multiply together all the numbers we had for our choices. This gives us 7 times 6 times 5 times 4 times 3 times 2 times 1. Typing this in our calculator gives us our final answer of 5,040. This question is quite similar to the previous one. The only difference is that we want 3-letter arrangements rather than 7-letter arrangements which used all the letters. Since we want 3-letter arrangements, we can think of this as having 3 boxes and needing to fill in each box with a letter from our word rainbow. As an example, we could fill in O, W, B. As another example, we could fill in A, O, N. We need to find the total number of ways we could fill in the boxes. The logic here is pretty much identical to the previous question. We've 3 boxes to fill, so we should break things down into the number of choices we have for each box. In the first box, we have all 7 letters of our word open to us, so we've 7 choices. Let's say I fill it with N. We can't use the same letter twice, so when it gets to the second box, I can't use N again. However, the other 6 letters in rainbow are still available, so I've 6 choices for the second box. Let's say I pick I. Now, when it comes to the third box, I can't use N and I can't use I. The other 5 letters in rainbow are still available, so I've 5 choices for this box. Let's say I choose B. So, how many total arrangements are there? Well, all we have to do is multiply together the choices we had for each box. This gives us 7 times 6 times 5, which is 210. In our table, the row with yellow is completely filled in. In particular, we're told that an angle of 45 degrees corresponds to a probability of 1 over 8. We can write this in equation form as 45 degrees is equal to 1 over 8. If we can find what 1 degree corresponds to, this will allow us to easily find all the other probabilities in our table. Well, to get from 45 degrees to 1 degree, we need to divide by 45. To find what fraction 1 degree corresponds to, we should divide 1 over 8 by 45. This gives us 1 over 360. So now we know that a 1 degree angle corresponds to a probability of 1 over 360. It's also possible to get to this result by using the fact that there's 360 degrees in a full circle. So, how can we use this to find our probabilities? Well, let's start with red. Here we have an angle of 72 degrees. If 1 degree corresponds to 1 over 360, then 72 degrees will be 1 over 360 times 72. If we type this in our calculator, it simplifies to 1 over 5. So this is our probability for red. Orange has a 30 degree angle. Again, if 1 degree is 1 over 360, then 30 degrees will be 1 over 360 times 30. Typing this in our calculator gives an answer of 1 over 12. So this is our probability of landing on orange. We can follow a similar procedure to fill in the rest of the blanks. Green has a 90-degree angle, so the probability will be 1 over 360 times 90. This comes out as 1 over 4. Blue has a 60-degree angle, so the probability will be 1 over 360 times 60. This comes out as 1 over 6. Indigo has an 18-degree angle, so the probability is 1 over 360 times 18. This comes out as 1 over 20. Violet has a 45-degree angle. This is the exact same angle as yellow, so it'll have the exact same probability, 1 over 8. Alternatively, we could have just multiplied 1 over 360 times 45, and it also would have come out as 1 over 8. A general strategy for calculating an expected value is the following. Multiply each probability with the corresponding value. Then add up all the results. We already know the probabilities for each of our colours. We also know the prize values for each of our colours. The first step is to multiply together the probability times the prize value for each colour. It'll be useful to extend our table with an extra column to write in these values. Red has a probability of 1 over 5 and a prize of 20. Multiplying these together gives us an answer of 4. Orange has a probability of 1 over 12 and a prize of 60. Multiplying these gives us 5. For yellow, we get 1 over 8 times 24, which is 3. For green, we get 1 over 4 times 8, which is 2. Blue gives us 1 over 6 times 42, which is 7. Indigo gives us 1 over 20 times 90, which is 4.5. And violet gives us 1 over 8 times 48, which is 6. To find our expected value, all we have to do is add up all these numbers. 4 plus 5 plus 3 plus 2 plus 7 plus 4.5 plus 6. When we do this calculation, we get an answer of 31.5. Since the prizes were listed in euros, the unit here is euro. The key to solving this question is the fact that the midpoint of a diameter is the centre of a circle. The midpoint formula on page 18 of the formula book will help here. It states that the midpoint between x1, y1 and x2, y2 is x1 plus x2 over 2, comma, y1 plus y2 over 2. We are given the two endpoints of a diameter, A, which is equal to 1, 8, and B, which is equal to 9, 0. If we find the midpoint of these 2 points, it will give us our centre. To use our formula, we'll label our first point with x1, y1. So here, x1 is 1 and y1 is 8. We'll label our second point with x2, y2. So here, x2 is 9 and y2 is 0. Let's sub these values into our midpoint formula. 1 plus 9 is 10, so our x-coordinate is 10 over 2, which is 5. 8 plus 0 is 8, so the y-coordinate is 8 over 2, which is 4. So the coordinates for our centre are 5, 4. To solve this question, we must have an understanding of what the word radius means. Well, the radius of a circle is the distance from the centre to a point on the boundary. In our circle, we've marked the centre in blue. A is a point on the boundary, so the radius would be the distance from the centre to A. If we can calculate the length of this line, we'll have our radius. There's a helpful formula on page 18 of the formula book. It says that the length of the line from x1, y1 to x2, y2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. We want the length of the line from the centre, 5, 4, to A, 1, 8. We'll label our first point with x1, y1. So here, x1 is 5 and y1 is 4. We'll label our second point with x2, y2. Here, x2 is 1 and y2 is 8. To find our radius, we just need to sub these values into our formula. One minus 5 is minus 4, and 8 minus 4 is 4. Minus 4 squared is 16, and 4 squared is 16. 16 plus 16 is 32, so we end up with the square root of 32. If we type this into our calculator, it automatically simplifies the expression to 4 times the square root of 2. We had to do this last step because we were asked to give our answer in the form p times the square root of q. The equation of a circle formula on page 19 of the formula book will help us here. It says that the equation of a circle with centre h, k and radius r is x minus h all squared plus y minus k all squared is equal to r squared. To use this formula, there's two things we need to know: the centre of the circle and the radius of the circle. Thankfully, we already know both of these. In part A, we found that the centre was 5, 4. In part B, we found that the radius is 4 times the square root of 2. In our formula, the coordinates of the centre are labelled with h and k. So here we'll have h equal to 5 and k equal to 4. To find the equation of our circle, we just need to sub into our formula. If we square 4 times the root of 2, we get out 32. So our final answer for the equation of the circle is x minus 5 all squared plus y minus 4 all squared is equal to 32. We are asked to find the equation of a tangent line. On page 19 of the formula book, there's a result which allows us to do this. It says that if a circle has centre hk and radius r, then the equation of the tangent at x1, y1 is x minus h times x1 minus h plus y minus k times y1 minus k is equal to r squared. In our formula, h and k refer to the coordinates of our centre. The centre of our circle is 5, 4. So here, h is 5 and k is 4. We found previously that the radius r of our circle is 4 times the square root of 2. Finally, we are asked to find the equation of the tangent at the point A, which is 1, 8. This gives us the x1 and y1 value for our formula. From here, all we have to do is sub our values into the formula and do some simplification. One minus 5 is minus 4, and 8 minus 4 is 4. On the right hand side, 4 times the root of 2 all squared gives us 32. Now let's multiply out the brackets on the left. X times minus 4 is minus 4x, and minus 5 times minus 4 is plus 20. Y times 4 is 4y, and minus 4 times 4 is minus 16. When presenting the equation of a line, it's conventional to write all the terms on the left-hand side and leave a 0 on the right-hand side. To achieve this form, all we have to do is subtract 32 from both sides. To finish, all we have to do is combine the number terms on the left-hand side. If we calculate 20 minus 16 minus 32, we get minus 28. So our final answer for the equation of our tangent line is minus 4x plus 4y minus 28 is equal to 0. We must find the area of a square, PQRS. In a square, all 4 side lengths are equal. To find the area of a square, we take our side length and we square it. The main issue here is that we don't know the side length of our square. Let's label this unknown with x. So, how can we find the value of x? Well, let's try to fill in some more information into our diagram. We know that the length from A to B is 7 centimeters. If A to Q is 5 centimeters, this means that there'll be 2 centimeters left over for Q to B. Now, we can exploit some symmetry in the outer square. B to R, C to S, and D to P will all be 5 centimeters also. R to C, S to D, and P to A will all be 2 centimeters. To find the value of x, we can use Pythagoras' theorem. This states that in a right-angled triangle with a hypotenuse of C and lengths of A and B for the other 2 sides, C squared is equal to A squared plus B squared. Let's zoom in to the bottom left corner and focus on the triangle APQ. Since we're told ABCD is a square, the angle at A is a 90-degree right angle. The hypotenuse is defined to be the side opposite the right angle. So here, the hypotenuse is x. The other 2 sides are 5 centimeters and 2 centimeters. We can apply Pythagoras' theorem with C equal to x, A equal to 5, and B equal to 2. Let's sub these values in. 5 squared is 25, and 2 squared is 4. 25 plus 4 is 29, so we end up with x squared is equal to 29. To find the value of x, we need to get rid of this square. The inverse of a square is a square root, so to get rid of this, we should square root both sides. On the left-hand side, the square root and the square cancel, so we end up with x being equal to the square root of 29. Now that we know the side length of a square, finding the area is straightforward. All we do is take the side length and square it. So here, the area of PQRS will come out as the square root of 29 all squared. The square root and the square will cancel, so we'll get a final answer of 29. The lengths in our square were labelled with centimetres. Areas are always presented in square units, so our unit here is centimetres squared. The formula for the circumference of a circle is found on page 8 of the formula book. It says that a circle with radius r has a circumference L given by L is equal to 2 pi times r. We'll use this result 2 times to find the circumference of the circle U and the circumference of the circle V. U has a radius of 4 centimetres, so here we'll put in a 4 for r. 2 times 4 is 8, so this gives us an answer of 8 pi. We're asked to give our answer in terms of pi, so we shouldn't convert this to decimal form. Our unit here is centimetres, since that was what was used for the radius. Circle V has a radius of 6 centimetres, so here we'll substitute in r equal to 6. 2 times 6 is 12, so the circumference of V is 12 pi centimetres. In part I, we found that the circumference of V is 12 pi centimetres. This means that if you drew a line along the boundary of V, the length of this line would be 12 pi centimetres. This means that one full rotation of V corresponds to a movement of 12 pi centimetres. It follows that 100 rotations of V would correspond to a movement of 12 pi times 100. This comes out as 1200 pi centimetres. Since our wheels are in non-slip contact, every bit of movement in V will cause the same amount of movement in U. This means that U will also undertake a total movement of 1200 pi centimetres. All we have to do is figure out how many rotations this corresponds to. Well, the circumference of U is 8 pi centimetres. This means that it takes a movement of 8 pi centimetres for one full rotation of U. So, we have a total movement of 1200 pi centimetres, and each rotation takes 8 pi centimetres. To find the number of rotations, all we have to do is divide these numbers. 1200 pi divided by 8 pi. Performing this calculation gives us our answer of 150 rotations. We can break up this construction into a number of steps. The length of the line AB is equal to 10 centimetres. This will be a good starting point. We can use our ruler to draw a 10 centimetre line. Then we can label the endpoints with A and B. The next bit of information is that the size of the angle CAB is equal to 60 degrees. Whenever we have this 3-letter notation for an angle, the middle letter is where the angle occurs. Here, that's A. So we'll want to use our protractor to measure out an angle of 60 degrees at A. Once we've measured this angle, we'll draw a faint line outwards. Our final bit of information is that the size of the angle ABC is equal to 40 degrees. Since B is the middle letter here, that's where the angle occurs. So the next step will be to use our protractor again to measure out an angle of 40 degrees at B. We'll draw a faint line outwards in this direction. So, we've drawn out one side of our triangle, AB, and we've measured out the relevant angles at A and B. The construction has already made out the shape of a triangle. To finish off, all we have to do is label our intersection point with C, and then to join this with solid lines to A and to B. In part 2, we're asked to measure the length of the line BC. Well, we have our triangle drawn, so all we have to do is to get out our ruler and measure the distance from our point B to our point C. Doing this gives an answer of approximately 8.8 centimetres. So this is what we'll write in to the answer box. To find our angles, alpha and beta, there's 2 key facts we need to know about parallelograms. The first is that opposite angles in a parallelogram are equal. The second is that angles which share a side in a parallelogram always add up to 180 degrees. In our parallelogram, the angle alpha is opposite the angle of 115 degrees. Since opposite angles are equal, this means that alpha will be 115 degrees. If we focus on the side SP in our parallelogram, we'll see that beta and the 115 share this side. Angles which share a side must add up to 180 degrees. This gives us an equation that beta plus 115 is equal to 180. If we subtract 115 from both sides, we get beta is equal to 180 minus 115, and this comes out as beta is equal to 65. We're asked to show that the triangle PQR is congruent to the triangle RSP. To help visualize this in our diagram, it will be a good idea to join P to R with a line. The 2 triangles we want to compare are PQR, which I've marked in blue, and RSP, which I've marked in red. To solve this question, there's 2 key facts we will use. Firstly, triangles which share 3 side lengths are congruent. So if we can show that the triangles PQR and RSP share 3 side lengths, then we'll know they're congruent. The second fact is that opposite sides in a parallelogram are equal. In our diagram, the side SR is opposite the side PQ. So these side lengths will be equal. the side SP is opposite the side RQ, so these two side lengths will be equal. So, let's look at our two triangles and show that they share three side lengths. The first thing to note is that our triangles share a common side, PR. So this is one side length that they have in common. We noted earlier that the length of SR is equal to the length of PQ. This was because they were opposite sides in a parallelogram. Also, the length of the line SP was equal to the length of the line RQ. Again, this was due to the fact that they were opposite sides in a parallelogram. Since we've argued that our triangles share three side lengths, we can conclude that they are congruent. We are asked to find the range of the rainfall data. So it's important to know the definition of this term. The range is the maximum value minus the minimum value. So to find the range of the rainfall data, we should identify the maximum and the minimum and then take these values away. Scanning through the rainfall data, the largest number we see is 155, so this is our maximum rainfall. The smallest number we see is 47, so the minimum rainfall is 47. To find our range, we subtract the minimum from the maximum. So we get 155 minus 47, which is 108. The unit for our rainfall was millimeters, so that's the unit we'll want to use here. In part 2, we need to find the year with the highest June rainfall. Well, we've already looked at our rainfall data and found the highest value. It was 155. This occurred in 2003. So the year with the highest June rainfall is 2003. In part 3, we want the year with the least June sunshine. To solve this, we'll need to scan through our sunshine data and look for the smallest number we can find. Once we do this, we'll notice that the smallest number is 124. This occurred in 2002, so the year with the least June sunshine was 2002. There's several approaches we could take to argue which of these had the best weather. Most people don't like having rain in June. So one reasonable approach would be to say that the best weather was the year which had the least amount of rain. If we scan through our rainfall data, we'll notice that the smallest value is 47, and this occurred in 2006. So we could argue that 2006 had the best June weather since it had the smallest amount of rain. There's several other approaches you could have used here, and as long as you justified your answer with data from the table, you would have gotten the marks. In part C, our first task is to write the rainfall data in increasing order. In other words, from smallest to largest. Well, in part B, we observed that 47 was the smallest value in our rainfall data. So let's start with this. Scanning through our numbers, we'll notice that 72 is the next smallest value. It's worth pointing out that I'm circling my values as I go along here, since this makes it easier to keep track of the numbers we've already used. Looking at our remaining data, the next smallest value is 84. The next smallest value is 94, and this appears twice, so we'll want to include this twice on our list. Next on the list will be 101, then 133, then 134, 149, and finally 155. So this is our data listed in increasing order. We're not done because we're also asked to find the median of this data. So what does this word mean? Well, the median is the middle value when our numbers are listed in increasing order. And if there are two numbers in the middle, then we should add them and divide by 2. So, to find the median, we'll need to identify the middle number or numbers. A nice way to do this is to repeatedly cross off the smallest and largest number on the list. To begin, we'll cross off 47 and 155. Then, we cross off 72 and 149. Next, we cross off 84 and 134. And then we cross off 94 and 133. We've now reached the middle, and there's two numbers which are equally central, 94 and 101. In this situation, the median is found by adding together the numbers and dividing by 2. So here, we'll get 94 plus 101 divided by 2. This gives us an answer of 97.5. The unit for our rainfall was millimetres, so that's the unit we'll want to use here. We're asked to find the mean number of sunshine hours. So how do we find this? Well, the mean is found by adding up all the values and then dividing by the number of values. We want to find the mean of the sunshine data. The first step will be to add up all these numbers. When we type this into our calculator, we get an answer of 1818. To find our mean, we should also count up the number of data values. Here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So the number of values is 10. To find our mean, we just have to divide these two numbers. It's 1818 divided by 10. This gives us an answer of 181.8 hours. In the next part, we need to identify which years had sunshine data within 5% of the mean. To do this, we should begin by calculating what 5% of the mean actually is. We found that the mean was 181.8, and when we multiply this by 5%, we get an answer of 9.09. So what we're after here is finding all the years which had sunshine data within a distance of 9.09 of the mean. We can concretely find our boundaries by subtracting and adding 9.09 from the mean. The lower boundary will be the mean, 181.8, minus 9.09. This gives us 172.71. The upper boundary will be the mean, 181.8, plus 9.09. this gives us 190.89. From here, all we have to do is scan through our sunshine data and identify the values which fall in between these two boundaries. 169 is not contained in between our boundaries. It's too small. 124 is also too small. 180 is between the boundaries. It's between 172.71 and 190.89. Similarly, 173 is contained within the boundaries. 239 is too big. 159 and 168 are both too small, and 228 and 205 are both too big. So the only numbers which fell between our boundaries was the 180, the 173, and the other 173. These correspond to the years 2003, 2004, and 2005. So these are the years that the sunshine data fell within 5% of the mean. Modern calculators have built-in functionality to calculate the standard deviation. We'll want to avail of this to solve this question. Here's a brief guide of the steps to perform for the Casio FX83GTX calculator. We begin by pressing the menu button. Then we'll press 2 to select statistics. Next, we'll press 1 to select the one variable option. From here, we need to type in our data. We want the standard deviation of the rainfall data, so these are the numbers we'll need to type in. 72, 133, 155, 101, and so on. After we've typed in our data, we'll press the OPTN button in the top left corner, and then we'll press 3 to select the one variable calc. When we do this, our calculator will display a number of statistics. The standard deviation has the symbol sigma x, and it can be found on line number 5. When we perform these steps, we'll get out an answer of 33.460573881. We're asked to present our answer correct to one decimal place, so we should round this off to 33.5. Since the unit for the rainfall data was millimetres, that's the unit we should use for our answer. In our scatter plot, the horizontal axis is labelled with the total rainfall. The vertical axis is labelled with the total sunshine. Each point we plot will contain a pair of these values, a rainfall value and a sunshine value. The first 4 points have already been plotted for us. The first pair in our table had a rainfall value of 72 and a sunshine value of 169. This corresponds to the point right here. The next point had a rainfall of 133 and a sunshine of 124. This corresponds to this point. 155 and 180 corresponds to this point, and 101, 173 corresponds to this point. We'll need to plot the remaining pairs ourselves. First up, we'll have a rainfall value of 94 and a sunshine value of 173. To plot this, we'll go to 94 on the horizontal rainfall axis and 173 on the vertical sunshine axis and plot a point right there. The next point has a rainfall value of 47 and a sunshine value of 239. So the point would be right here. The rest of our points can be plotted in a similar way. This question involves a correlation coefficient. There's two key facts we should keep in mind here. Positive correlations have an upward trend, and negative correlations have a downward trend. Also, the larger the correlation, the stronger the trend. If we look at our points, we'll notice that they follow a downward trend. This means that the correlation will be negative. This rules out 0.6 and 0.1. A correlation coefficient of 0 means that there's no relationship or trend between our two quantities. Correlations which are close to 0, such as minus 0.1, means that there's almost no trend at all, and if there is one, it will be very difficult to notice. Since our data does contain a noticeable downward trend, we can rule out the minus 0.1. So our answer here is minus 0.6. Our justification here is that our data contains a noticeable downward trend. In this question, we are prompted to use the theorem of Pythagoras. This can be found on page 16 of our formula book. It states that in a right-angled triangle with a hypotenuse of C and lengths of A and B for the other two sides, we'll have C squared equal to A squared plus B squared. Here, the word hypotenuse refers to the side which is opposite the right angle. We need to find the length of the line R to Q. Let's mark this unknown with X in our diagram. Now, let's focus on the right-angled triangle RPQ and apply Pythagoras' theorem. In our formula, C represents the hypotenuse, the side which is opposite the right angle. Here, that's the 6.5. The other two sides of our triangle should be labelled with A and B. Here, I'll label the X as our A and the 3.3 as our B. Now, let's sub into our formula. 6.5 squared is 42.25, and 3.3 squared is 10.89. To find the value of x, we'll need to rearrange our equation into the form x is equal to something. Our x appears on the right-hand side, and to isolate it, we'll need to get rid of the square and the plus 10.89. The opposite of addition is subtraction. So to get rid of a plus 10.89, we should subtract 10.89 from both sides. Performing the calculation on the left gives us 31.36 is equal to x squared. Since the opposite of a square is a square root, the next step will be to square root both sides. Performing the calculation on the left-hand side gives us our final answer. X is equal to 5.6. Since all the other lengths in the triangle are measured in meters, that's the unit we'll want to use here. The angle alpha appears in a right-angled triangle, RPQ. The SOHCAHTOA result is very useful in this situation. This can be found on page 16 of the formula book, and it says that if we're given an angle A in a right-angle triangle with hypotenuse H, opposite O, and adjacent A, then sine of A is equal to O over H, cos of A is equal to A over H, and tan of A is equal to O over A. To use this result, we must label our triangle appropriately. The angle we are concerned with is alpha, so let's label that with A. The hypotenuse H is the side opposite the right angle. In our triangle, that corresponds to the 6.5 meters. The opposite O is the side opposite our angle of interest. Here, that's the 3.3 meters. The adjacent A is the third side which is remaining. Here, A is equal to 5.6 meters. Each of our three trigonometric ratios, sine, cos, and tan, involve 2 out of the 3 sides of the triangle. Since we actually know all 3 sides of the triangle, we have some flexibility here. Sine, cos, and tan are all options that will work. I'm going to pick sine and use the fact that sine of A is equal to O over H. We have alpha in the place of A, O equal to 3.3, and H equal to 6.5. So let's sub these in. We're trying to find alpha, and this appears on the left-hand side of our equation. However, it appears inside a sine. We'll need to get rid of this to find alpha. Whenever we want to remove something from an equation, we need to perform the inverse to both sides. Our calculator has a built-in function, sine inverse, which is defined to be the inverse of a sine. So we should take sine inverse of both sides. On the left, the sine inverse and the sine cancel. Now, performing the calculation on the right-hand side gives us an answer of 30.5102. We are asked to present our answer correct to the nearest degree, so rounding this off, we get alpha is equal to 31 degrees. The key to solving this question is the fact that angles on a straight line always add up to 180 degrees. If we focus on the line from P to S, we'll notice that the angles on this line are 31 degrees and beta. Since angles on a straight line always must add to 180, we get the equation that 31 plus beta is equal to 180. To find beta, all we have to do is subtract 31 from both sides. This gives us the answer that beta is equal to 149. In this question, we are prompted to use the cosine rule. This can be found on page 16 of the formula book, and it states the following. Given the 3 sides, A, B, C, and the angle A squared is equal to B squared plus C squared minus 2bc times the cosine of a. It's worth emphasising here that the side which is labelled with lowercase a must be opposite the angle which has been labelled with uppercase a. Due to symmetry, the other two sides can be labelled b and c in any way we want. So, we're asked to find the length of the line from R to S. Let's label this unknown with X. This side appears in the triangle RQS. Let's focus on this when applying our cosine rule. The cosine rule only involves one angle, capital A. We only know one angle in our triangle, 149 degrees. So let's label this with capital A. The side opposite this angle must be labelled with lowercase a. So here we'll label the x with a lowercase a. We can label the other two sides with b and c in any way we like. Here I'll label b as the side which is 8 metres long and c as the side which is 5.6 metres long. Now that we've identified the values for all our letters, let's go ahead and sub into the statement of the cosine rule. From here we can simplify. 8 squared is 64, 5.6 squared is 31.36, and, using our calculator, minus 2 times 8 times 5.6 times cosine of 149 comes out as plus 76.8022. Adding up the numbers on the right hand side gives us x squared is equal to 172.1622. To find the value of x, we'll need to get rid of this square. The inverse of a square is a square root, so here we should square root both sides of our equation. When we perform the calculation on the right hand side, we get x is equal to 13.1211. Since we're asked to give our answer correct to the nearest metre, we round this off to get a final answer of x is equal to 13 metres. In this question, we need to find the length of an arc. There's a result on page 9 of the formula book which will help here. It says that the length of the arc, L, from an angle theta in a circle with radius r is L is equal to 2 pi r times theta over 360 degrees. We want the length of the arc from T to S. To be able to use our formula, we need to know the size of the angle which spans this arc. Let's label it with x. Finding this isn't too difficult. We have a fact that the angles on a straight line always add up to 180 degrees. If we look above the line from R to T, the angles that are on it are 149 and x. Since angles on a straight line must add to 180, we have x plus 149 equal to 180. To find x, we should subtract 149 from both sides. This gives us that x is equal to 31 degrees. An alternative approach to finding this angle would be to use the fact that opposite angles are always equal. In our formula, theta refers to the angle spanning the arc. Here, we'll have theta equal to 31 degrees. R is equal to the radius, and in our diagram, this is equal to 8 meters. Let's sub these values into our formula. Performing the calculation on the right-hand side gives us L is equal to 4.3284. We're asked to give our answers in meters correct to one decimal place. So rounding this off gives us our final answer of 4.3 meters. We must find the area of the sector SQT. Looking to page 9 of the formula book, there's a helpful result here. It says that the area of the sector A from an angle theta in a circle with radius r is A is equal to pi r squared times theta over 360 degrees. In this formula, theta refers to the angle which spans the sector. In our diagram, we'll have theta equal to 31 degrees. R is the radius, and in our sector we have a radius of 8 meters. To find the area of our sector, all we have to do is sub in these values to our formula. When we do the calculation on the right, we'll get out 17.3137. We're asked to give our answer in square meters correct to one decimal place, so rounding this off gives us our final answer of 17.3 meters squared. To find the volume of a sphere, we can use a result on page 10 of the formula book. It states that the volume V of a sphere with radius r is V is equal to 4 over 3 times pi times r to the power of 3. We are told that the sphere has a radius of 0.3 centimeters, so this should be our value of r. Let's sub this into our formula. Performing the calculation on the right-hand side gives us 0.113097. We need to give our answer in centimeters cubed correct to 3 decimal places. Rounding this off gives us our final answer that the volume V is 0.113 centimeters cubed. We are told that each centimetre cubed of pure gold weighs 19.3 grams. We can formulate this in an equation by stating that 1 centimetre cubed of gold is equal to 19.3 grams. In the first part of the question, we found out that the sphere contains 0.113 centimetres cubed of gold. So, how many grams does this correspond to? Well, our amount of gold has changed from 1 centimetre cubed to 0.113 centimetres cubed. In other words, it's been multiplied by 0.113. The grams will be scaled in the exact same way. So all we have to do is multiply 19.3 times 0.113. This gives us an answer of 2.1809 grams. Since we need to give our answer correct to 2 decimal places, we should round this off to get a final answer of 2.18 grams. We are told that there is approximately 6.02 times 10 to the power of 23 atoms in 197 grams of gold. We can formulate this in an equation as follows. 197 grams is equal to 6.02 times 10 to the power of 23 atoms. In the previous part of the question, we figured out that our sphere contains 2.18 grams of gold. So the question here is, how many atoms does this correspond to? Getting from 197 to 2.18 directly is a difficult task. It's not immediately obvious what the scaling factor should be. To make things easier, we can find what 1 gram corresponds to as an intermediate step. To get from 197 to 1, all we need to do is divide by 197. Dividing the grams by 197 will also divide the atoms by 197. So the number of atoms in 1 gram will be 6.02 times 10 to the power of 23 divided by 197. This gives us 3.0558 times 10 to the power of 21. Now, to get from 1 gram to the target of 2.18 grams, all we have to do is multiply by 2.18. The number of atoms will scale in the same way, so this should also be multiplied by 2.18. When we perform this calculation, we'll get 6.6616 times 10 to the power of 21. We need to present our answer in the form a times 10 to the power of n. Our answer is already in this form. The a corresponds to the 6.6616, and the 10 to the n corresponds to the 10 to the 21. However, we need to write a correct to 2 significant figures. In other words, we only want to keep 2 non-zero digits. The first non-zero digit is the 6 before the decimal place, and the second non-zero digit is the 6 after the decimal place. And this is all we'll want to keep. However, since the next digit, 6, is greater than or equal to 5, we'll need to round upwards. This brings us to our final answer of 6.7 times 10 to the 21 atoms. The key to solving this question is the fact that the margin of error is 1 divided by the square root of n, where n is the sample size. In this question, we have a random sample of 1,560 viewers. So the sample size, n, is 1,560. Subbing this in, we see that the margin of error is 1 over the square root of n, which becomes 1 over the square root of 1,560. Typing this in our calculator gives us an answer of 0.025318. We must give our answer as a percentage. To convert from a decimal to a percentage, we multiply by 100. Another way to think of this is that we move the decimal point 2 slots to the right. So, as a percentage, our answer is 2.5318%. We need to present our answer to 1 decimal place, so rounding off gives us our final answer of 2.5%. This question involves calculating a 95% confidence interval. This can be broken down into a number of steps. The first step is to calculate the sample proportion and margin of error. In our survey, 546 of the 1,560 viewers said that they liked the show. To find our sample proportion, we just need to write this as a fraction. 546 over 1,560. In the first part of the question, we found that the margin of error was 2.5%. It's a bit awkward having the sample proportion in fractional form and the margin of error in percentage form. So let's convert the sample proportion into a percentage. Using our calculator, we can rewrite 546 over 1560 as 0.35. To convert from a decimal to a percentage, we multiply by 100. So this becomes 35%. We are now ready to start calculating the bounds for our interval. The lower bound of the interval is the sample proportion minus the margin of error. Here, that's 35% minus 2.5%, which is 32.5%. The upper bound of the interval is the sample proportion plus the margin of error. Here, that's 35% plus 2.5%, which is 37.5%. It is conventional to present our interval as follows. We write the lower bound and the upper bound separated by a comma, all enclosed in square brackets. So here, the 95% confidence interval is 32.5%, 37.5%. In this question, we must conduct a hypothesis test at a 5% level of significance. This procedure can be broken down into a number of steps. The first step is to state the null hypothesis, H0, and the alternative hypothesis, H1. In our scenario, the executive claimed that 40% of the viewers liked the show. Usually, the null hypothesis will involve equality and will correspond to whatever claim is being made. If we let P represent the percentage of the viewers that like the show, the executive is claiming that P is equal to 40%. This will be our null hypothesis, H0. The alternative hypothesis, H1, will involve inequality and usually corresponds to the claim not being true. Here, the alternative hypothesis, H1, is that P is not equal to 40%. The second step in our procedure is to create a 95% confidence interval for the data. Thankfully, we've already done this in the previous part of the question, and the 95% confidence interval we found was 32.5% to 37.5%. Step 3 involves the following. We need to look at the assumed value for the null hypothesis. If it is inside the confidence interval, then we fail to reject H0. If it is outside the confidence interval, then we reject H0 and move to H1. In our scenario, the null hypothesis states that P is equal to 40%. So the assumed value is 40%. This value is not contained in our confidence interval of 32.5% to 37.5%. 40% is too big. Since our value was outside the confidence interval, we reject H0 and move to H1. The final step is to state our conclusion in the context of the question. Well, we rejected H0, the executive's claim that P was equal to 40%. Instead, we opted for H1, which stated that P is not equal to 40%. So our conclusion is that we reject the executive's claim and conclude that the percentage of the viewers who like the show is not 40%.